Good morning, children. Today we are going to start with chapter 7, Sound. Okay, so the first part of it you studied in 9th standard about propagation of sound and other things. Now we are going to see some other areas about sound. Okay, now the first part, A part, reflection of sound and echoes. Now, actually, before going to reflection of sound, they have given all the introduction, a recap of all that you studied in class 9. So, usually questions don't come from this, but a quick recap of what you know already. Okay, first is audible range of frequency, 20 hertz to 20,000 hertz. You know that. And then sound above 20,000 hertz is called ultrasonic, and sound below 20 hertz is called infrasonic. So human beings cannot hear ultrasonic and infrasonic, but there are some animals which can produce and hear these sounds. Okay, so then you know this formula, relationship between speed of sound, frequency and wavelength. V is equal to F lambda. This is the relationship between all the three. Then coming to this part, the propagation of sound. So you know that sound travels as mechanical waves. Why do we call it mechanical waves? Because sound waves are produced due to vibration of medium particles. Vibration of medium particles. So you call it mechanical waves. Okay, literally the particles of the medium have to move. That's why they're called sound waves. Now, so sound waves are generally mechanical waves. That's the first thing you studied. And then mechanical waves are of two types: longitudinal wave and transverse wave. Longitudinal wave and transverse wave. Now, longitudinal means the vibration of the medium particles is parallel, like crest and compression and rarefaction. Compression followed by rarefaction. So this longitudinal wave, medium particles vibrate like this, wave is also going like this. Whereas in transverse, medium particles vibrate up and down and the wave will be traveling like this. So you will get, your wave will be like this with crests and troughs. Okay, so longitudinal waves has compression and rarefactions, travels in the form of compression and rarefaction. Transverse waves has crest and trough. Then which medium? First is this one. Second one, longitudinal waves are generally produced in solid, liquids and gases. Longitudinal waves can be produced in all three mediums, whereas transverse waves can be produced only in solids and surface of liquids. Surface of liquids. It needs a stable medium, so to produce this kind of waves, so solids and surface of liquids. So quickly we can underline all that. Mechanical waves, longitudinal and transverse, compression and rarefaction. So you don't have to study, children. It was just to recollect. So longitudinal waves are produced in longitudinal waves are produced in solid, liquid as well as gas. Transverse waves are produced in solids and surface of liquid. Okay, and then you know that sound wave travels as mechanical waves, whereas light waves travel as electromagnetic waves. So they can travel in vacuum, but they cannot travel through vacuum. They need a material medium. Then speed of light, 3 into 10 power 8 meters per second, which is very, very high. Whereas speed of sound is just 330 meter per second in air. So, right, now we come to the actual syllabus. It starts from here, reflection of sound waves. Reflection of sound waves. So far we have studied about reflection of light waves. So what is reflection? Bouncing back of light into the same medium. Same way, reflection of sound means when sound hits an obstacle. Okay, The obstacle may be a wall or a or a um, or a cliff or something. So when the sound hits a wall or a cliff or something, it can get reflected. Okay, it can get reflected. So this is, so whenever there is an obstacle, sound gets reflected. That's the first thing. Okay, now this phenomena, as you know, is called as echo. The reflected sound that we hear is called as echo. Okay, so this is a common term which we use in our daily life, echo. Okay, now you don't hear echo. Now first is the definition of echo: the sound heard after reflection from a distant obstacle such as cliff, hillside, wall of a building, etc., after the original sound has ceased is called an echo. Okay, sound heard after reflection from a distant obstacle. Okay, that is clear, understood. After the original sound has ceased. What is the meaning of this? Now, to understand that, you have to understand another concept called persistence of hearing. Persistence of hearing means anything that you hear in your ear. Okay, if I say a word that stays in your ears for 0.1 seconds, that's called persistence of hearing. It seems to be very less, right? But so it stays in your ears for 0.1 seconds, right? That's why many times the instructions and all which teachers tell, you're not able to retain because you have a reason for that, right? But now the point is, if the reflected sound, so original sound, suppose you're producing a sound, okay, and this sound, that original sound stays in your ears for 0.1 second. And so there are two things now: original sound and then the reflected sound. Now the reflected sound, if it reaches before 0.1 seconds, you cannot differentiate reflected sound from the original sound. That is, you cannot hear an echo. Is it clear? If the reflected sound comes before 0.1 seconds, that means in case of close obstacles, okay, in cases where obstacles are close to the object, you don't hear echo generally, because the reflected sound reaches before 0.1 seconds, and for 0.1 seconds your original sound itself is there in your ears. So that's the reason why you don't hear echo. Same thing happens in a classroom and all. Though there are so many obstacles, though there are walls around, still we don't hear echoes mostly unless you shout very loudly. So why? The reason, because the distance between the source of sound and obstacle is so less that the reflected sound reaches before 0.1 seconds, and that is why you cannot differentiate original sound and echo. Okay, it will appear to be original sound only. So the condition for echo, okay, the condition for echo to be produced is the sound should reach your ears at least at 0.1 second or above that. At least the minimum distance is minimum time is 0.1 second. If it comes before this, you cannot hear a sound. So the minimum time for an echo to be heard is 0.1 second. So from this, it helps us to find the minimum distance. Now, another thing you have to understand, for echo to be produced, the original sound, suppose if this is the distance between the person and the obstacle, okay, the sound has to travel, the echo before reaching his ears has to travel 2D. Why? It has to go hit here, D, and then it has to come back along the same path, another D, D plus D, 2D. Okay, so so our formula for velocity, we know that velocity is distance upon time, but in case of echo, distance will be 2D. Okay, the sound has to travel a distance of 2D upon T. So speed of sound in air, we all know that it's 340 meter per second. Roughly it is 340 meter per second. So 340 is equal to 2d upon 0.1. Okay, it should reach minimum at 0.1 or after that. So I cross multiply it. So I get 2d is equal to 340 into 0.1 will be 34, or d is equal to 34 by 2, that is 17 meter. Now 17 meter is the minimum distance between the source and obstacle. If you have to hear an echo, at least the obstacle should be at a distance 17 meter in front of the object. So you can imagine 17 meter is quite a big number. That's the reason generally echoes and all you hear in open areas, and when you shout in front of a mountain and all that, you hear an echo. Why? Because the obstacle is at a larger distance. Okay, so this leads to the next topic, that is, so all that is explained here. Now three conditions must be satisfied for us to hear this echo distinctly. Three conditions. What are the three conditions to be satisfied to hear the echo? First is minimum distance. The word minimum is very important. Don't write distance between source and reflector is 17 meter. No. It can be 17 meter or more than that. So the minimum distance between source and the reflector of air should be 17 meter. Then second one, size of the reflector must be large enough as compared to the wavelength. Okay, the reflector size should be large enough, then only it will be able to reflect. And the third, the intensity of sound should be such that the reflected sound reaching the ear is sufficiently intense to be audible. Now, because the sound has to travel a distance of 2d, it has to go here and then come back. Now, if already you produce a weak sound, okay, it will get lost by the time it goes and comes back. So you should produce a sound of high intensity, means loud sound should be produced, then only it will have energy to go and come back and you will hear at least some sound. Okay, that's the third condition. Intensity should be high such that it can be reflected also. Okay, then in the numericals involved, or in case of echo, the formula that will be involved is V is equal to 2d by t. Okay, now in this, there's another term called reverberation. Reverberation is echo getting prolonged. Okay, sometimes multiple reflections happen and the echo will be prolonged like this, like hello, it keeps going on and on, right? I'm sure you would have heard it, especially in some closed tombs and all that. Okay, they've written in Taj Mahal, Sikindra and all that. If you go inside and shout hello, you will hear one long hello like that. Okay, why? Because multiple reflection will happen from the reflected sound gets again reflected. That happens. That's called reverberation. If there are repeated reflection, the sound gets prolonged. This is called reverberation. Okay, just an information. Three conditions that to be satisfied should be remembered. Now we go to uses of echo. So many of them you've studied last year itself. So we'll have a quick recap. First one, why is ultrasonic waves used in most of the applications? Why? They have three properties. Last year they said you have two properties. Now they have written as three. Okay, they can travel undeviated through a long distance. Second, they can be confined to a narrow beam. Third, they are not easily absorbed in a medium. So all these three properties make ultrasonic waves suitable. Audible sound does not have these characteristics. Ultrasonic waves have these characteristics. So in most of the applications, all these applications that we see will be using ultrasonic waves and not ordinary sound waves. Okay. Now first use of echoes by bats, dolphins and fishermen. This also you had last year. Bats and all, like they cannot see during the daytime, but how do they recognize their obstacle? They keep sending ultrasonic waves in different directions, and whichever direction there is an obstacle, it gets the echo back. It gets a reflected sound. Then it can even gauge or decide how far, in which direction and how far the obstacle is. Okay, so this process of detecting obstacle is called sound ranging. So what is sound ranging, they ask sometimes. Process of detecting obstacle is called sound ranging, and explain it with respect to bats. So you can write this explanation. Dolphins also can detect their enemy and obstacle by emitting ultrasonic waves and hearing their echo. And trawlermen or fishermen, okay, when they go for fishing, they use a ultrasonic pulse from a source into the sea. So as they go into the sea, they keep sending ultrasonic waves, and from whichever direction they get a reflected ray, they know that there is a fish or something is there, so they will go in that direction and try to catch a fish. Okay, and receives the pulse reflected from the shoal of fish in a detector. Okay, so trawlermen or fishermen also use ultrasonic waves to detect fishes and in the direction in which they are present. Okay, then the second is sonar. Sonar stands for sound navigation and ranging. So these are devices fit on ships. Okay, these are devices fit on ships. Okay, sonar device, these two together is called a sonar. A sonar will have a transmitter and a receiver. So transmitter will produce ultrasonic waves and receiver can receive ultrasonic waves. So it will produce ultrasonic waves and send it down, and wherever there is an obstacle, okay, there is an obstacle, it gets reflected and comes back. So the receiver can receive that signal and it can do the calculation and tell you exactly at what depth you have this obstacle. Or sometimes if they want to know the depth of the sea also, they can send a ultrasonic wave inside the sea. It gets hit at the bottom and it comes back, and if you calculate the time taken by that from using the formula V is equal to 2D by T or D is equal to VT by 2, you can get the depth. So this process is called echo depth sounding. The depth of the sea found using reflection of sound. Okay, finding the depth of the sea using echo of sound is called as echo depth sounding. Where is it used? Sonar. It is used in sonar. Okay, radar also uses it, but they don't use sound wave, they use radio waves. Okay, so it's given as an extra information. Radio detection and ranging. Radar is used in flights and all that. So when a flight is flying, the radar will keep sending signals in all directions to find the presence of any obstacle or any enemy flight in its range. So they send electromagnetic waves. Okay, microwave, radio wave or microwave. Okay, right. Then the third one, use of echo in medical field. So this is a common thing. We have heard about ultrasonography. This is to image the human organs like liver, gallbladder. This is the most common technique that is used in medical field. Similarly, ECG, to image to get an image of the heart, they do echocardiography, that is to get an image of the human heart. That helps them to find out if there is any problem in those body parts. Now, we'll go quickly to the numericals. Not too complicated, but definitely one question comes from these exercise. Okay, so the first I think 7 numericals. Okay, the first 7, 1 to 7 numericals are just based on formula V is equal to 2D by T. So in case of echo, the formula that we'll use is V is equal to 2D by T. So either they will give you velocity and time and they'll ask you to find distance. Okay, so let me just do sixth question for you. Question 6. A man standing 48 meter away. So distance is 48 meter. Fires a gun. Calculate the time after which he can hear an echo. The speed of sound is 320 meter per second. So these two are the informations given and you have to find T. So V is equal to 2D by T and so T will be 2D upon V. So 2 into 48 upon 320. So if you solve this, you'll get 0.30 second. That's the answer. Okay. So numericals 1 to 7, it's directly based on this formula. So it will be easy to solve. You can start solving from 6. Okay. 6, 7 like that. 6 is done. 7 you do it. Now 8, 9, 10 and 11 are little different. They are little more complicated. Usually you get one of these questions because it comes for 3 or 4 marks. Okay. So I'll be doing 8th question. A pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires the gun simultaneously. He hears echo from the cliff after 8 vibrations of the pendulum. If the velocity of sound in air is 340 meter per second, find the distance between the cliff and the observer. So it is simply like the usual one, but in this case, instead of using, usually they use a stop clock or something to note the time. Okay, time taken by the sound to go and come back. But in this, they are using a pendulum. In this, they are using a pendulum. So this leads to one more calculation. Okay, so this particular pendulum produces 5 vibrations per second. Okay, 5 vibrations are produced in 1 second. Okay, now that is the original characteristic of that pendulum. Now in this particular case, okay, he started the pendulum when the sound was sent. He started the pendulum and he heard echo after 8 vibrations. That means the sound has taken 8 vibrations of the pendulum to come back. Okay, so the echo has been produced in this much time. I don't know, I can't solve it in vibrations. I want it in seconds. So we are going to use this relationship to convert it. It was given that 5 vibrations are produced in 1 second. Therefore, 8 vibrations would have been produced in 1 by 5 into 8. 8 by 5, that is 1.6 seconds. So time is 1.6 seconds. Simple as that. Okay, instead of giving time as 1.6 second, they have given you a little bit complicated to confuse you like this. So no worries. So 5 vibrations are produced in 1 second, and if it is given, it took 8 vibrations to hear the echo, then 8 vibrations are produced in this much second. Okay, so then speed of sound is 340. You have to find the distance. So V is equal to 340 meter per second. V is equal to 2D by T, or D is equal to V into T by 2. So velocity is 340, T is 1.6 upon 2. So you'll have 170 into 1.6. That will give you 272 meter. So this is one type of question. Okay. And the other type is the next two sums. A person standing in between two vertical cliffs produces a sound. Okay, I'm not going to solve this. This will be homework. I'll do the example sums so that you will be able to try that as homework. Example number 8. Okay. Or example number 8. Okay. A man standing in front of a vertical cliff fires a gun. He hears the echo after 3 seconds. On moving closer to the cliff by 82.5 meter, he fires again and hears the echo after 2.5 seconds. Okay. So a man was standing in front of a cliff. Okay. So a man standing in front of a cliff fires a gun. He hears echo after. So when he fired from here, he heard an echo after 3 seconds. On moving closer to the cliff by 82.5 meter, means from here, he has moved closer to the cliff. That means, and what is this distance? 82.5. Yes, he's moved by 82.5 towards the cliff. Sometimes in the numerical, they can give you away from the cliff, then it will come here. Okay, now so from this position, now he's come forward. From this position, when he produced an echo, this time he heard echo after 2.5 seconds. After 2.5 seconds. So the question is, find the distance of cliff from the initial position and then speed of sound. Okay, now let us take this distance as d. The initial distance, the original position ka distance from the cliff, let it be d. And the time taken in that time is 3 seconds. Okay, so speed of sound is given as, speed of sound we have to find, right? Speed of sound we have to find. Okay, now let's take this is position A, position B. Okay, in position A, the position A distance is d and time is 3. So V is equal to 2d upon 3. 2d upon t. Okay, so 2d upon t is the formula. 2 into distance is d and time is 3 seconds. Position B. When he comes to position B, what is the distance between B and the cliff? Now that is not 82.5. That's the distance between A and B. But I need the distance between B and the cliff. That will be D minus 82.5. Did you understand? This is D. He's moved forward by 82.5. Therefore, this distance will be D minus 82.5. So in this case, you'll have V is equal to 2 into V will be the same because the same medium, speed of sound is going to be same. Instead of D, you have D minus 82.5 upon, and this is produced in 2.5 seconds. Okay, so at A position, V is equal to 2D by 3 you get. At B position, V is equal to this much you get. Now, both the velocities are same because the medium is the same. So, I can equate these two. 2D by 3 is equal to 2 into D minus 82.5 upon, don't write seconds here, upon 2.5. 2 and 2 will get cut. Then you solve, you cross multiply it. So, 2.5D is equal to 3 into D minus 82.5. So, bring the D terms together and then if you solve it, you will find D as 495 meter. Okay, D comes out to be 495 meter. So, once you know that's the first part, then second part you have to find the velocity of sound. So, you can put it in any formula, 2 into D upon 3, 2 into 495 upon 3. So, that will give you 330 meter per second. Okay, is it clear, children? So, same way, this sum number 9 is also, 10 is also of the same type. Okay, here moves forward, and then this sum is also very easy. A person is standing between two vertical cliffs. Two successive echoes are heard at 4 seconds and 6 seconds. So, in this case, a man is standing between two cliffs, one nearer one, the other one is a farther one. From the nearer one, he hears an echo after 4 seconds. From the farther one, he hears an echo after 6 seconds. That's all. So, this is what you should know. The nearer one, the first echo comes from the nearer one, the second echo comes from the farther one. So, speed of sound is given, time is there. You can find this distance as D1, this distance as D2, and then distance between two cliffs, D1 plus D2. So that is also easy. So the homework will be, okay, anyway, so from 6 to 11, okay, 7 and 8, 6 and 8 I have solved, but in your notebook, I want this to be continuous, 6, 7, 8, 9, 10 and 11. Okay, try this definitely. One question definitely comes, children. If you want, see the example again, that will help you. Thank you so much.